Hello everyone, hope you all are doing very well. For those who are new to my channel, my name is Avkash, and if you are interested learning how you can take any existing large language model, whether it's open source or proprietary, in both way, if it has ability to fine tune and can be extended for your own document, this video is for you. In this video, you are going to learn by using GPT Index or LlamaIndex open source library to fine-tune a large language model just by writing 3 or 4 lines of code, and then using the generated index, loading it, and then querying whatever questions you have, also in 2 to 3 lines. So just under 10 lines of code, you can actually fine-tune a large language model, and you can also ask question from it. Here in this demo, we are going to use the Gradio based application to first fine-tune the OpenAI large language model by providing this archive tool former language model that can teach themselves to use, and we are going to ask questions based on this document which we have just used to fine-tune it. First, we need the OpenAI API key. Here is the OpenAI key. OpenAI key is set. In the next step, I would be taking this PDF which I have already downloaded and drop it here. This is the PDF. Once this PDF is downloaded, I will use this option to create index. This PDF has been transformed into the text, and then this text has been fed into the large language model available at the OpenAI cloud is GPT, and based on input text, the index has been created. That index is actually downloaded on the local file system, and that is the index name here. So if we would want to ask question based on this document, we have to load the index, and if I run this command, as you could see that this document shows that we have this index available. So I'm using this index file as the source and I'm loading the index. After that, the index is set. It means now I can ask question about this particular content. So first thing I can ask, what is this document about? At this point, the large language model, which is hosted at the OpenAI cloud, and I'm connecting it through the API by using the OpenAI API key. And here is the answer to our question. The document is about tool farmer. If we can ask other questions such as, who are the authors of this document? And as you can see that these are the authors, and the OpenAI answered this question to one. So this application is designed to not only process the PDF, you can actually use the text document. The idea is that any source content you are giving, it's processed into the text, and then after the text is used to train or to fine-tune the large language model, and that's how you are going to get output from it. Before we go and dive into the coding part of this demo, let's just spend a few minutes to learn the fine-tuning method or the need of third-party or the open source library to fine-tune a large language model, whether it is hosted at OpenAI or you can use any open source model which is actually downloaded on your local machine, or you can host that model, or that model is already hosted at the third-party repos such as Hugging Face as well. So before we go and look into the code and learn how to extend any large language model which has capabilities to be enhanced through the external data source, let's spend some time and look into that the need for fine-tuning as well as how it is possible, means how a large language model can be fine-tuned for the external data sources. First, we already know that we have a large language model. Depending on its capabilities, the data it has been trained, and the methodologies it has been trained by. You have your large language model could be a size of few million parameters all the way to few billion parameters. Larger the large language model, better it has capabilities to answer your question and the capabilities surrounding the type of topics it can answer your question very well. The basic type of questions are general question answering, text summarization, getting something new out of your large language model. We already know that the basic large language model are designed to take the text as input prompt. Based on input prompt given to your large language model, you get the text output. However, the large language model is not limited to just giving the text output. Actually, what you are getting is the numeric representation of the text, which is output. And because the input text prompt as well as the output text prompt, they both are generated based on a common embedding or the text embedding dictionary. Depending on whatever source language you have, you can very easily understand the numeric text representation is basically the encoded value of your output text. Here is an example where we are asking this large language model to write a haiku about train. Haiku is like 3-line poem from Japanese context. Here is the output: raindrops falling fast, nature's music fills the air, life is renewed, refreshed. This text output actually is the numeric representation of this text output is going to look something like that. Basically, every word it's encoding in a vector format or the vector representation of your text. That is what you are getting from your large language model based on your giving text input. However, the large language models can be multi-modal. It means not only processing the text content as input, you can actually pass the image as a prompt, or you can also add audio as a prompt or video as a prompt. The very new, very recent ChatGPT 4 model, which is available through the ChatGPT premium service, like a paid service, is actually using the multi-modal version of the ChatGPT. Just an extra notification or as an example to give you an example of multi-modal large language models. The output is still the text output because these models are the large language model or the language model. Inherently inside, even when your multi-modal inputs are not only text but image, audio or video, everything has been translated or the pre-processed into the text prompt internally, and then that text is being fed into the multi-modal or the multi-modal large language models as text input, and output is going to be the text output. However, in future, these large language models will be combined with other generative AI models where you are actually using image, audio or video as the input, and output can also be the non-text output, something what your target type output is, whether it's image or audio or video, because the large language model can be combined with other models programmatically and then you can get output that way. But the large language models are created as a language processing, or they actually process language and generate language. So that's why they call large language models. In future, things could change in very differently. So we know that large language models are trained on a very large amount of data, web scale data, and this data has been used to train these large language model, and the bigger the input or bigger the training size is, that's why we say the large language models have billions of parameters because they are trained for a very large input data. So the question comes, how a very large large type of this input text content has been created into or transformed into a large language model. Your language or your content or anything else is not being sitting inside the large language model. The large language model is trained based on how this content is written, and then after, when you are asking question or when your prompt is being processed by the large language model, this large language model actually knows the output language if it is English, and based on that it actually generates the tokens based on what is really thinking. So it is not like it's reading the text and then composing something and then creating for you. No, everything is being created on the fly. So the word as a tokens are created on the fly based on the semantic of the language, and that's how the question which you have asked is answered by the large language model. The objective for this video is not to show you how this training happened, but why we are going in the route of the fine-tuning a large language model. So we know that the most popular but a very popular technology to generate the large language model is the transformer-based technology. I wouldn't go really deep about it. However, the idea of transformer is the groundbreaking research behind the generation or behind the creation of these large language models. So we take very large amount of data, and with the help of very large amount of compute resources and the transformer technology available, or they produced, or they I would say they came out from the Google, is the basis of breaking down this very large piece of source content and distribute it. And on a distributed platform, it is trained. And that training is actually what makes or generate these large language models. So the first thing what we do is that we take the input data and then we convert it to the text embeddings, basically the encoding, so that it can be processed properly by the machine learning or AI algorithms. And that's where your source data is no longer needed. Now the text with embedding is the source for the training. And that's what generates your large language model. And that's how you can, just in a nutshell, take the idea that the large language model is created based on the text embeddings of the source data. And reason why we are using this word here, because that is an important aspect when you are going to enhance a large language model through the libraries or publicly available libraries, so that you can ask question about a text which these large language models are not trained for. We already gone through this, and this is how you get the answer to your prompt based on quick understanding of the training with very large data. So one of the biggest example as of now is the ChatGPT. There are several other open source or the proprietary large language models available from Facebook, OpenAI, Google, and other third-party, I would say, open source companies such as Big Science. They have Bloom, and there is another Neo GPT. There are a variety of them, so there is significant amount of research has been done to generate these large language models, which you can download if you have resources available on your machine, and you can try locally or at ChatGPT, kind of these large language models which are hosted at the creators' resources, such as for the OpenAI, wherever it is hosted, and using the API, you are accessing it. So most of the time, or the most popular uses of these large language models, which we have seen very recently, is the model is hosted in the cloud and you are connecting this model through the API. So if the model is hosted in cloud and you would want to train may not be a good word, fine-tune this large language model with your own custom data, how you can make it possible. And that's where the role of fine-tuning large language model through various third-party libraries comes into the existence. And so the concept is still the same, that how we are going to connect these large language model with the external data sources so that we could fine-tune them and fine-tuning process is quite similar to the one which we have seen earlier when we were talking about training. And very first thing, we take the external document and we break it down into the indexes, and these indexes actually have the encoded content as well as lots of other information which actually convert source document to the indexes. And then we do not really need this source document at all. These indexes are used to fine-tune the large language model, and once the fine-tuning is completed, the large language model in conjunction with this external document index, now this is the model which you have, which can actually answer question based on your own document. And that's where the fine-tuning part take over. However, in order to answer the questions such as what is this document about, you are actually asking a very large language model to refer this external document index, which I have just used to fine tuning, and using that index, the ChatGPT can still use, or any large language model can still use its own knowledge how to write the language, how to interpret the input question and refer to this external document index, and combining all the knowledge it already had before as it was trained, it can actually generate answer to your question. And that is what the fine-tuning of very large language model is. After the brief introduction, now it is our time for us to learn how we can use the Python code, just few lines of code, to first fine-tune a large language model to generate the indexes. And after the indexes are generated, we can load that index to ask question, query, summarization, question and answer, whatever our objective is, with our large language model, which is already connected through our index, which we have already created previous. So the coding will be done in two separate files. First, we are going to use the fine tuner, which is just 3 or 4 lines of code, and then we are going to use the query indexer, which is also a few lines of code. So just in 10 lines of code, you are going to see how to fine tune a large language model with your custom source index. I do have the PyCharm open, and let me open the terminal. The configuration which I'm using is the Python 3.10, and the runtime Python environment is actually using the Conda runtime. And as you can see here, that this is the Python 3.10 and pip info, and I do have the GPT Index is already installed here, pip show. So GPT Index has been already installed in this machine, and that's where the 0.4.30 is version, which is we are using is the same LlamaIndex right now. So you must have that package installed, and cancel. I will clean this code. So I'm creating the main, which is the training part. So I could say that this file actually is the fine-tuned.py, and then we are going to create the query.py. So first training, reading the source document and generating the index out of it, and the query, reading the index and answering your questions. So first import GPT Index, that's we are going to use, and from GPT Index import, and at this point we can look into the GPT Index documentation. And first we need to know that from GPT Index we really need to import the simple, as you can see here, simple. So simple web page reader, Mongo reader, directory reader. So because we are going to read the data from directory, so let's use the directory reader. Then we also need the GPT simple vector index. It means document has to be read from local file system, and then we need to convert that to the vector index. So these two modules we needed from the GPT Index. So first we are going to use this simple directory reader. Simple directory reader, you can actually look into the documentation if you are interested. Here is the example, simple directory reader. In simple directory reader, you will pass your input directory and then you can load data from it. So simple directory reader will going to read your location. So we need to create a new location here. You can create source data is the folder, source data dot load data, and this is going to read the data from this folder. So the content which is here is going to be read, load data, and we can say loaded content equals. So this loaded content has the text after we have read the files available in this folder, and then we are going to use this GPT simple vector index, and this is what is going to generate the index. This method is going to use loaded content as input, and it is going to generate the output index, and this index is actually going to save to the disk. So if you will say here, you can also save to the disk here, save to the disk and path. So here we can say that output index dot save to the disk, and here we can say that output data is going to be saved into the folder called index data, and within the index data we could say slash index.json, and that's what the output data is. And these 3 lines of code is all you really needed in order to read the data and save that data as the JSON. Once it is there, now we need to make sure that we have access OpenAI subsystem which can perform this job. So before even we go there, let me run this code and let's see what happened. Let's put the breakpoint here. We are at the very first line, and at this point I will drop a raw txt file in the source data folder. There you go. So the source data has a file. I have already dropped this. It's just some text content I have just copied here. Now let's run this code. As you can see that loaded content is nothing but the text file, and this method does not need any access to OpenAI library. Only thing needed when we are converting the loaded text to the output index. At that point, because we do not have access to a LLM model as of now, if we try to go next step, we are going to get an exception, and as you could see here, it said did not find OpenAI key. Means it needed the OpenAI key, and it's asking us to use this variable OpenAI API key. So we need to set this OpenAI API key, and the way you can set this OpenAI API key is in the environment variable. So we could say import OS and OS dot environment. I think it's the OS dot environment, and within the environment you can actually, this is your variable, and at this point you can actually use your key. So OS dot environment, and then if you can set your OpenAI key, let me see where my key is. Okay, this key I'm just using right now. After this tutorial I will change my key, so this key will not be accessible to you, so please do not use it. So this is the OpenAI key. I have set it up. Let me close this debugging, and as you can see here, it is trying to look into the text DaVinci 003 model. At this point, default LLM. Let's clear it. Let's run this code again. So this OpenAI API key has been set. Loaded content, we have already seen. At this point we can go next, and at this point this content which we have already processed has been sent to the OpenAI subsystem, and after that the output index has been generated. Looking into the output index, as you can see that it has all that information which is needed for the large language model to answer your question when this index is loaded. So I will close this, and we will save this open index to the index data index.json, and here is our index.json. So that index has been saved in local file system, and that is what your fine tuning is. So just using 3 lines of code, you have actually created the index. Now we are going to create the query application. Let's call it queryindex.py, and we are going to use same thing here. Actually, we need to read the index first. So here the GPT index and OS needed, and we need to make sure that we do have API key available when we are going to use the query index. So that is set for us. We have used GPT simple vector index. So same thing, from GPT index import GPT simple vector index, because this is what we have used. So you can say, and now index has to be loaded first. Load from disk. So load from dictionary, load from disk, load from string. So we are saying that, okay, you can load from disk, and here we have same path. This is our complete path, and that's what gives the index. So we could say loaded index equal. And if you look into this, if you say dot, and here you can actually query it. So once this thing is loaded, this is our loaded index query. So your query is a method, and here you can ask your question. So I would say prompt is equal to what is this text about, and that's where the prompt is going to be used here, and that's pretty much it is. So let's put a breakpoint here. Now we can debug it. Let's run loaded index. At this point, request went to the OpenAI backend through API, and using this index, now you have the loaded index available. You can take a look here. That's your loaded index, and then using the loaded index, you are asking the question, and here is your prompt, and now the request going back again to the OpenAI subsystem, where we are working with the tax, the DaVinci model 003. And now we have just got the output here. We can actually run this code, and this text about the how artificial intelligence can transform the DevOps. That's where the document was. We can convert this code so we can get to use the same index again and again, and the output will be written here. So print. Okay, save it. Let's remove this breakpoint, run this code. Here is our prompt. We can say, give me top 5 questions about this document. Here are the 5 questions which are available in this document. What are the objectives of DevOps and how AI can help? You can say exit. The knowledge which we have learned, fine-tuning as well as using the index to perform the queries, is going to help us to build this Gradio UI based application, where we are going to train or fine-tune the OpenAI model for documents as well as the PDFs, and we could ask, and that will be the part of our second presentation. So this was the part first of our tutorial. In the second part of the video, we are going to start immediately writing Gradio UI based application with multiple tabs, so that first we can use various text and PDF documents to generate the indexes actually based on source documents, and using the index we can ask queries whatever you have with the help of OpenAI large language model. Thank you so much for your time. I hope you have enjoyed the video, and I'm looking forward to seeing you in my next video. Until then, thank you so much.